Hi, my name is Jackie.
I'm Isabel.
I'm Matt.
And I'm Josh.
We are the WPI Waterways team, and welcome to Foster Community Gardening.
This garden is one of 11 managed by Honolulu Department of Parks and Rec.
This is where we will primarily be working.
Let's take a look at some of the other gardens.
Welcome to the Diamond Head Gardens. These gardens are a very important part of the community and serve as one of the most prized spots for garden plots. Welcome to Manoa Gardens. Here we are in the valley where the gardens are lush and colorful.
This is an example of a compost system run by the gardeners. When the compost system becomes full, a volunteer will turn it. Next to it is garden tools left out in the open because there's not a lot of crime around here.
Welcome to Makiki. This garden is a little different than Foster and Manoa. The gardeners lock up their plots in order to prevent theft and vandalism.
They also have these mailboxes for the gardeners to share information between the community.
Welcome back to Foster. Here, the gardeners pay 10 cents per square foot for watering their garden.
With the cost of water increasing, our sponsor, the Honolulu Department of Parks and Recreation, has been looking into ways to conserve water in their community gardens.
Their goal is to reduce the usage of city water over time to keep the cost of water low for gardeners and to encourage more sustainable watering practices.
Our job is to build a rainwater catchment system and provide informational materials to help the gardeners meet their goal.
The design for the rainwater catchment system consists of 4 4x4 posts cemented into the ground. On the joist hangers are 6 2x4s that are 8 feet in length. 3 supports are placed in all 4 corners of the roof frame. One support sits horizontally in the frame of the roof, another support connects the post to the crossbar, and the last support connects the post to the roof frame. The gutter is attached using K-style gutter hangers and is slanted towards one end. Finally, 5 10-foot by 2-foot sheets of corrugated galvanized steel are screwed onto the roof.
Another important part of our project was to reach out to the community. This involved interviewing gardeners and experts in the field. We did this in order to better understand the needs of the gardeners and to figure out what their understanding of water conservation was.
To begin our project, we measured out and marked where we wanted the center of our 4 posts to be, which was 9 feet 4 inches by 7 feet 7 inches.
This is where the lovely grounds person John came and delivered all of our supplies. He delivered all of our wood in his truck, and he also ended up lending us his personal tools like a square and a level so that way we could do our project successfully. For our project, we were given limited supplies in the beginning because of the lack of knowledge of the different tools that were available to us. We ended up nailing in the stakes into the ground with a shovel because we were using what we had.
We use stakes and tape to mark where all the holes are going to be, and we also use fishing line and a square to make sure everything was at a 90-degree angle.
After we finished marking where we want our foundation to be, we began by digging 2 feet deep holes with a 1 foot diameter.
The biggest challenge on day 1 was the large amount of rocks in the ground. Even the auger we had couldn't break through them, so we had to dig around them and pull them out by hand.
Well, after about 6 hours of digging, 2 members from the grounds crew came over, saw these 3 holes that we started but had yet to finish, and saw the household auger that we were using, and then told us that they had an industrial size auger that could get through all the rocks and could finish the holes in 10 minutes.
When we showed up the next morning, most of the dirt was still in the holes from when the grounds crew used the auger.
We used gravel to make sure that the concrete forms were set and level in the holes and make sure that they fit in the holes we dug.
At the end of the day, we roped off the area so no one would fall in the holes.
For day 3, we worked on cutting up one of the concrete forms that was 4 feet in length and 1 foot in diameter, and we needed to fit in the holes we had, so we cut them in half to make 2 feet deep concrete forms, just like we did the previous day.
We used 10-foot 4x4 beams for the main posts. We used a circular saw to cut them to height, and we measured them to make sure they were level and all in the same height. At the top of each post, we attached brackets so that way we would be able to attach the roof and later the supports.
To make sure that the posts stayed vertical and didn't move when we were pouring the concrete, we attached two 2x4s to each pole that we were able to plant into the ground so that they wouldn't move during the process.
We started off by mixing the water and cement into the buckets, but we quickly realized that it was more effective to put small increments into the form. We did this until the form was filled up to the top.
On day 4, we started setting up the last 2 posts similarly to day 3. We made sure that they were level and the correct height. We also applied the brackets on the top of them so that way we can attach the supports, made sure they were all steady and ready for concrete.
Once again, we braced each of the poles with 2 2x4 planks. We also added one more brace that connected the new pole to the one we completed yesterday to keep them lined up.
The 4x4 wood beams that were going across the posts that we put in the ground for the roof frame were too large to fit within the sides of the bracket. Previous day, we started with a small handsaw to try to shave off the sides of the 4x4 beams, but that took way too long and way too much energy. So today, a member from the grounds crew came over and brought us a chisel and a proper workbench. And with the chisel, we were able to shave down the sides enough to fit within the brackets.
After the concrete set, we took off all the braces on our structure. Then, we began putting up the other beam across the 2 posts to support the roof structure.
In order to make sure that the beams laid flush with the other beams we had already set up, we had to make some small cuts that made the beams look similar to Lincoln logs. What we found worked best was that we marked the beams and then cut them with the sawzall, and then used the chisel to break away the extra wood. We measured out exactly where the hangers needed to be to hang up the rafters on the structure, and then we drilled them into the wood and then attached the beam to the top of the structure.
In the original drawing, we had the slope of the roof was 6 degrees, but when we went to recalculate that based off of everything that we'd actually built, it ended up coming out to about 4 degrees. So when we noticed this difference, we went to test to see if the water would still flow down the roof by putting the gutter piece that we had up on one of the beams and seeing if the water flowed, which it did. We accidentally cut one of the rafters short by a few inches and ended up not being able to sit on the brackets. This was the one beam that we messed up on, but we did end up finding a purpose for it on the last day.
At the end of this day, we ended up with a structure that had rafters going across. One of the limitations that we came across during day 5 was that our lag screws had a tendency to break when we were screwing them in. We were using impact drill, and they ended up breaking quite frequently, which resulted in us requesting for more materials from our sponsor.
For day 6, we put up the last rafter. We put 2 lag screws on the outside of each rafter beam in order to keep our structure more stable.
Most of our day consisted of cutting the corner supports. We put these up so that way the structure wouldn't be able to twist or sway in either direction. We measured and cut the beams for the corner support at 45, 49, and 41 degree angles. We found that we used a combination of the handheld circular saw and a jigsaw to make these cuts straight.
We ended the day by hanging up the gutter at a slope so the water would flow down. We then tested it with a hose to make sure the water flowed properly, and as expected, it worked.
On day 7, it was finally time to start putting up the roof. We moved the panels that our sponsor had bought for us, and we measured out how much overlap we should use. Then we moved each panel up to the roof and screwed them in using roofing screws. These were very strong and easy to go through the wood because they were very sharp.
So next we decided to build a stand for our IBC tote in order for the water to be gravity fed down so the gardeners can use it. We built the stand by using cinder blocks and we placed them in the corners of where the tote would be. We did end up moving them in order to better fit the IBC tote and be more stable.
On day 7, we also found a use for the beam we cut too short on day 5. We used it to create a wood frame that connects the downspout to the top of the IBC tote, as well as keep it stationary and stable.
Throughout the week, we found that the rainy season here in Hawaii was starting, and periodically throughout the week it would rain during the day, and specifically on this last day we found a lot of rain, which was great for testing our product. By the end of the week, we had a finished product of a rainwater catchment system with this canopy. We ended up having lots of conversations throughout the week with excited gardeners, very happy to have something new and exciting in their garden and something to look forward to moving forward with rainwater conservation. As a group, we came up with a catchy name as the Rainwater Recycler. This is going to be branded on the outside of the tote as a nice sign and encouraging the gardeners to use the rainwater that we collect.
We did a quick test with a hose, and the water quickly flowed down the roof, into the gutter, and into the tote. It was important that we tested it because the tote contained seed oil, since it was a recycled tote from our kitchen. It even rained later that day, and we noticed that the tote was partially filled with the newly caught rainwater. After 7 days of building, we wanted to make the canopy more visually appealing and fit in with the culture of the garden. We used rocks that we dug out from the ground to create a border for our garden. We then spread soil and placed succulents around the garden. Next, we mulched the garden to help retain the moisture. Finally, we used gravel to create a pathway under the canopy.
Additionally, we built a demonstration garden beside our canopy. We planted vegetables and herbs such as spoon tomatoes, radishes, oregano, and more. While planting, we utilized good gardening practices such as mulching and mounding. The purpose of this is to be utilized as a demonstration garden for school field trips on educating students about good gardening practices and the importance of water conservation by looking at our water catchment system.